Hello everyone and welcome to this lecture in the hands-on large language models series. Today we are going to look at one of the most emerging and trending topics in large language models, and that is the topic of agents. So let me switch to a different color at the start. All right. Today we are going to build and create our own agent. And there are many people who are still confused between what is a large language model and the difference between LLMs and agents. We'll see the difference between LLMs and agents, and we'll also understand the hype behind agents. Towards the end, we'll go to Google Colab and we'll build our own agent and see it in action. So, if you are following the large language model space closely, up till now, you must have seen that agents are extremely popular. If you just search LLM agents funding, look at the amount of funding or the investment which has flowed into this space. It's around $87 billion invested across 443 companies in the LLM agent space, right? That's pretty awesome. Second, there are many Reddit threads, many forums in which people are discussing that what's the hype behind agents and why is everyone talking about agents so much. Even recently, at the NeurIPS 2024 keynote speech, Ilya Sutskever talked about the fact that he believes that pre-training is coming to an end and the next generation models he predicted are going to be agentic in real ways. So everywhere around you, we are seeing this trend that humanity is slowly moving towards a place which will be governed by agents. And agents can be powerful. Agents can be a bit scary also if you truly understand what all they can do. But first we need to really understand what agents are to understand this hype behind agents. Alright, so let's begin today's lecture with a simple understanding of agents and how they differ from large language models as we know so far. So until now, all of us have seen large language models that follow user-defined steps, right? So let's say if I go to ChatGPT right now and let's say if I ask something that create a cooking recipe for me. I want to eat Indian food, let's say. And you will see that the large language model responds with a recipe for paneer butter masala. This is the output which large language model provides to me. And that's pretty awesome. Up till now we have seen this, that LLMs follow user defined steps. So one of the most promising concepts in large language models is their ability to determine the actions which they can take. And this keyword actions is what differentiates LLMs from agents. Let me give you a simple example, right? Let's say if you want to go from Pune to Boston, and let's say if you want to book a flight, what can ChatGPT do? Let's see. So I'm going to ChatGPT right now and I'm saying that I want to book a flight from Pune to Boston on, let's say, 18th December. Show me some travel plans, let's say. And you will see that here are some of the options which ChatGPT provides to me right now. The main thing though here is that although the responses are provided by ChatGPT, it cannot go ahead and do the entire booking process for me, right? So there are a number of actions which need to be performed from this initial stage. So let's say I'm at point A right now where I'm sitting in Pune and I want to go to point B where I want tickets. I want my flight tickets printed and available to me on my laptop, let's say. Now, if I am to go from point A to point B, we have to do several steps in the middle, right? The first step is to search for flights. That's the first step. The second step is to choose. The second step is to choose the flight which, let's say, has the lowest rate, which has convenient timings. So there are a number of things in this choosing step also. And then the last step is go to the website and book the tickets. So there are three actions which need to be performed if I want to go from point A to point B. A large language model which cannot perform actions will just tell me that these are the three steps you should do, but it cannot take me from point A to point B, right? If you see what the GPT-4 has done right now, it actually did the first action, I think. It has actually searched for flights, and that's because GPT-4, the way it's advanced, it's integrated with some flight booking applications, and it's integrated with some apps which it can go and it can search. So that much it has done. That's good. So it has done probably the first part of this, but it has not yet done the second part of this. It has not yet done the third part of this. Imagine a world in which you have a flight agent. Imagine a world in which you have a flight agent. What this flight agent will do is that a human, let's say I am sitting here right now, I just make a request that I want this flight to be booked, and the flight agent is an AI agent, of course, or an LLM agent, which does all of these three steps. It searches for flight, it chooses the best flight, and it even books the flight, it makes the payment, and it sends me the flight tickets. So it sends me the tickets. This is what agents can do. Agents have autonomy, which means they can take actions. That's the most important thing. So imagine living in a world where you are just sitting and you tell an AI agent that, hey, book this flight for me, and it's automatically done. Remember, it's not a real person here, but this is the promise where people think the large language model space is evolving. I'm just showing you a flight agent here, right? There can be a restaurant agent, restaurant booking agent. There can be, let's say, if you are wanting to learn a subject, there can be a curriculum curator agent. There can be so many agents in your life that imagine a world in which you are living and you have 50 agents at your disposal, just doing one or the other task. And people believe that we are headed into such a world, and that's why there is a lot of investment which is flowing into this agent space. But I hope with this example you understood the difference between large language models and agents. Just large language models cannot perform any action. Even here right now, if you see, the reason GPT gave me these routes and gave me information about these airlines is because it's doing a web search. That's an action. So this can actually be called as an agent. If you remember, GPT 3.5 could not do this, but now web search is integrated within GPT itself. That's an action. So when an LLM performs an action, it suddenly becomes an agent. That's the main difference here. So that's how you should think of LLMs versus agents, and I will talk a bit more about this point in subsequent just right now itself, so that this idea becomes clear to you. Formally, agents are defined like this: systems that leverage a language model to determine which actions they should take and in what order. So remember this flight booking example which we took. The agent will of course use a large language model, and it will use it to decide, it will search for flights, it will choose the best option, and it will do the booking. So the order is also important. We cannot do it in the reverse manner, right? We cannot book the flight first, then choose the flight and then search for flights. Although it sounds intuitive to humans, it's actually quite a challenging thing to do it completely autonomously through agents. So agents are systems that leverage a language model to determine which actions they should take and in what order. So just remember this keyword action, which differentiates LLM from agents. Now, earlier in this lecture series, we have seen that using LangChain, we can do a huge number of things, right? Especially we can do 4 things using the LangChain framework. We can do model input and output. Here we saw about quantization. We can add memory modules, which we saw that there are 2 types of modules. There is a conversation buffer and there is summarization. We have not yet seen retrieval, but up till now we have seen that LangChain can help us assemble multiple of these modules together. Now the thing with agents is that agents can make use of everything which we have seen so far. Agents can make use of model input output, agents can make use of chains, agents can also make use of memory. But the main difference between just an LLM framework and an agentic framework, when you use agents, it's also called agentic framework. The main difference between an LLM and an agentic framework is that agents use tools. That's the most important thing to remember. So again, let's look at our flight example, right? If you want to book a flight, there are three actions which need to be performed, right? First is you need to search. Second thing, you need to decide or choose. And third thing you need to do is pay. Now, for each of these actions, remember that these actions cannot be done unless the LLM has access to tools. What are the tools which are needed? So, for a search, we need access to a search engine. We need access to a search engine like Google. So, the LLM will be given access to this tool. So, the LLM, imagine the LLM as the smartest person in the world, but they don't have access to tools. They are not very useful, right? But now we slowly start equipping the LLM with weapons, with tools. One such tool we give the LLM is the Google search engine. To make the payment, we equip the LLM with payment gateways. We equip the LLM with access to payment gateway tools. So if you are in India, the payment gateway tools can be, let's say, Razorpay. If you are watching this from US or Europe, let's say the payment gateway can be Stripe. These are the tools which the LLM needs to have access to. So another major difference between agents and LLMs is that agents use tools, and tools that the agent can use to do things it could not do itself. So without searching the web, the agent will not be able to search the different flights, right? Without having access to these payment gateway tools, the agent will not be able to make the payment on its own. In fact, if I go here right now and if I search, I want to book a flight, you will see that, look at the initial few seconds, you will see that searching the web. See, you will see searching the web. That small thing which you saw, that's the tool which this LLM has been given access to. That's the Google search. Let me show you again. So if you search this, see this searching the web. This is a tool which the LLM has been given access to, right? And see, here are the answers which the LLM provides to me right now. So this LLM which I'm interacting with is actually an agent because it's coupled with a tool. The tool of searching Google. Okay, so agents have access to tools. That's the one thing we learned. Second, which is also very important, is that we have to specify the agent type which plans the actions to take or the tools to use. So imagine that you are a soldier and you have 100 weapons at your disposal. You still have to choose, right, which tools to use and which not to use. That itself turns out to be a difficult decision, and that's why developing powerful agents is not such an easy thing to do. That's another reason why there is so much hype and investment flowing into this space. We have not yet developed extremely powerful production level agents. You'll know it is developed when, let's say, if you're interacting with 10 people on a everyday basis, right? At least 3 or 4 are using agents. That's when you know that agents have come into the normal population. Just how ChatGPT came into the normal population after it became a product. So the agentic frameworks are at a stage where there is a huge amount of progress which is being made, but it will still take time to make it into a product. And companies which make agentic products, they will probably become extremely rich and huge companies, because these products will be used by people all around the world like you and me. Alright, so until now we have seen two main keywords associated with agents. The first is they take action. The second is they are equipped with tools which LLMs on their own are not equipped with. So second thing is, unlike chains which we have seen so far, agents can also do advanced actions like creating and self-correcting a roadmap to achieve a goal. Let me give you a simple example regarding this. Let's say you want to develop a Python code, right? So if I go to ChatGPT and I say, write a Python code for calculating the sum of two digits. It's pretty simple code which I am asking here right now. And let's say a particular code has been generated, right? But now let's say this code is wrong. And then what you have to do is that then I have to say that this part of the code is wrong, correct it, etc. So I provide the instructions, right? I provide feedback. So there is a human in the loop. Imagine if this is completely done by two agents. So imagine that there is an agent 1 and there is an agent 2. What's the main purpose of agent 1? The purpose of agent 1 is to generate the code. Actually, one more thing I would like to mention here is that even if this code is generated, I still need to execute it somewhere else. I need to execute it on my Python, right? So that's another step which I have to do on my own. So there are three things, right? First is the code generation, second is the code evaluator itself, and third is the code executor. Here, just the code is being generated, but the evaluation and the execution I have to do on my own. So now what if it's done by three agents? So first agent generates the code, second agent executes the code in Python, code executor, and then agent 3, what agent 3 will do is that agent 3 evaluates the code or evaluates the results. Now imagine these three agents working together. They won't need the assistance of a human because let's say agent 1 generates the code. Agent 2 has access to a tool. It has access to, let's say, Python environment where it can run the code by itself. So we don't need a human here. And agent 3 can analyze the results here and then it can provide feedback. It can provide feedback to agent 1 regarding how the code needs to change. Based on the feedback, agent 1 changes the code. Again, agent 2 executes it. Again, agent 3 evaluates it. So imagine this entire loop. This entire loop can keep on going for, let's say, for complex codes, if it goes for 20 to 30 times or even more, the final code which you get will be a code which is fully optimized and fully checked. That's an example of a process in which agents correct each other without humans in the loop. That's why it's mentioned that unlike the chains which we have seen so far, agents can do advanced actions like creating and self-correcting a roadmap to achieve a goal. That's the power of agents. If you really understand how agents work, you can completely automate your workflow by assigning different tasks to different agents. So one takeaway until this part of the lecture which I want all of you to remember is that agents can actually interact with the real world through the use of tools. And these tools can be search engine, payment gateways, access to Python code environments, any type of tools, apps, calendar apps, any type of app or tool which you can visualize. So I generally like to provide a simple example here. Again, as a disclaimer, I am borrowing this code and this example pieces from this book, hands-on hands-on large language models by J. Alamar, one of the finest books I've come across related to practical large language models. So the example which this book provides is that LLMs are generally not that good at mathematical problems, which all of us might have experienced at one point or the another. And why this happens, there is a whole lot of reasons for this. I believe it's because of the tokenization issues, but let's come to that later. Now, let's say the LLM does not have access to tools, right? And you are asking it some complex mathematical operation and the LLM provides an answer which is wrong. Now, what if you give access to a calculator to the LLM and you say that, hey, I know that you are not doing a good job at maths, no problem, I'll give you access to a tool. And the tool which I'm going to give you access to is a calculator. So then what the LLM does is that it has suddenly become an agent. An LLM with tools is an agent. So now when you ask this calculation to the LLM, it does not try to do it on its own. It uses a calculator, it gets the answer and the answer is correct. So giving LLMs the ability to choose which tools they use for a particular problem results in more complex and accurate behavior. Let me repeat that again. Giving LLMs the ability to choose which tools they use for a particular problem results in more complex and more accurate behavior. So let's look at what's written on this side of the page. Agents utilize LLMs not only to understand our query but also to decide which tools to use and when. So that is the tricky part of agents. As I said, imagine you are a soldier with 100 weapons, right? You are a useless soldier if you don't know which weapon to use. So LLMs first have to understand our query, then they have to decide which tool to use, and then they have to deploy the tool. So if you think about it in a flow, they first have to understand the query, then they have to decide which tool they want to use, and then they have to deploy the tool. So they have these three things to do. Now, the why have agents become so useful recently, and what's so hard? Uh, why is there such a big leap from LLMs to agents? Let's understand about this a bit. So it turns out that LLMs are good at reasoning, right? We saw several techniques to even improve LLMs at reasoning. We saw the chain of thought prompting. We saw the tree of thought prompting. There are several different ways LLMs can reason, but getting them to act is not very easy. Here is a text which has been taken from the hands-on LLMs book. Let's see what the authors write. Acting is a bit of a different story. LLMs are not able to act like you and I do. To give them the ability to act, we could tell an LLM that it can use certain tools like a weather forecasting API. However, since LLMs can only generate text, they would need to be instructed to use specific queries to trigger the forecasting API. So if you ask LLM what's the weather, it does not know the weather by itself, right? It has to query a weather API and then get the weather from there. So getting the LLM to act is not easy. And now this has been integrated in ChatGPT. So I believe that if you ask ChatGPT what's the weather, it will query an API and it will take an action. But the earlier versions said that I cannot retrieve real-time information. But now GPT-4, I have started to look a bit of like an agent because of these things. So if I ask what is the weather in Pune, let's see the answer. So it's searching the web and see it has made this API call, and that's why it is giving me the exact weather right now. Because it has access to tool, it has made the API call and then it has received the weather for weather prediction and it has showed me this weather here right now. But getting LLMs to act like this is not very easy. That's what the authors are trying to say here. When the first GPT papers were published, they were more about getting LLMs to predict the next word or the next token. And then we thought about reasoning, but no one really thought about acting. And how can we get the LLMs to act? And that's where agentic frameworks bridged that gap. So let me write this down here. Earlier the focus was a bit on next token prediction. Then we got the LLMs to reason. And then after that, what agents did was they combined reasoning with acting. So if you combine reasoning with taking action, then that leads to a strong agentic framework. In fact, there was a very famous paper which came out, I think it was like 1 or 2 years back. It's called as React, Synergizing Reasoning and Acting in Large Language Models. The paper describes exactly what we discussed right now. So what the paper says is that large language models are getting better at reasoning. For example, chain of thought prompting and acting. But these two directions have remained separate. So they proposed a framework called React, which is reasoning and acting. And in this framework, the reasoning capabilities and the acting capabilities were fused. So when the React framework was constructed, it suddenly served as the foundation to building agents. So if you think this is the foundation, so this is just like building has foundation, right? Similarly, this is the React framework, and the React framework is the foundation for agents or for building agents. So that's the best way to think about the React framework. In fact, we have been learning about LangChain, right? LangChain There is a way to implement React in LangChain, and we are going to see a hands-on demonstration very soon. But just remember that this paper which I showed to you right now was the one which started this thinking, and then this React framework was even implemented in LangChain, which is now used by researchers and LLM practitioners to very frequently code agents on their own. So let's understand this React framework a bit better before we jump to the hands-on coding section. So React merges reasoning plus acting and allows reasoning to affect acting and actions to affect reasoning. So it's like, you can think about it like a loop. So here also, if you see, it's like a loop, right? So the loop is that reasons, of course, when you reason about something and you think, that affects your action. And then when you do the action, you observe something, right? You observe something and then that affects your reason as well. So it's like a cyclic framework. And you will see these cycles being mentioned in this paper also. I'm not going to go through this paper right now in detail, but I'll mention a link to that in the information section. So there are 3 steps of the React framework. The first is thought, then action, and then observation, right? So think about this as the TAO, which is first you have to think. After you think, you have to take an action, and based on your action, you have to observe what you have, what is the result you get, and then you have to repeat this process again. So let's see a simple example here. If the instruction is solve the question from the user, then the React steps are thought, action, and observation. So then the thought can be about current situation, what the user has asked. Then you have to decide the action. So when you decide the action, you have to also choose the tool, choose the correct tool, which you have to use from your toolkit. Remember, we talked about tools before and a soldier being equipped with tools. Here is the place where you have to choose the tool from the toolkit. Then you have to deploy the tool. And then you have to observe what is the result of deploying this tool. So that's how the thought, action, and observation framework works. Now what we are going to do is that we are going to take a very real life example and we are going to code our first agent using the React framework in Python. So let's start understanding the example which we are going to look at. So imagine you are on a holiday in the USA and you want to buy a MacBook Pro. As a human, I can just Google, right, and see MacBook Pro price. MacBook Pro price dollars, let's say, and I can go to Apple's website and I can see the price for MacBook Pro here, right? But the goal is that I want to know its price in euros, because let's say I live in Europe. So what I want to do here is that I'm, let's say, on a holiday in the USA. So I'm originally let's say from Europe, and I'm on a holiday in the USA right now. And in the USA is where I want to buy the MacBook, right? I want to buy the MacBook here, but I want the price to be shown in euro, because only then I can compare it, or I can think about it in my currency. So now first think about how you will solve this problem as a human. What will you do? Pause this video over here and think about the steps which you will do as a human to solve this problem. Let me tell you what I will do first. First I will Google and I will get the MacBook Pro price. And that will be in dollars. Then I will use a currency converter and convert dollar to euro, and then I will get the MacBook Pro price in euro. So actually, if you think about it, initially I thought what I have to do, right? That's the first part. I thought about what I have to do, and then I thought that I will search. So this is the first action, this is the second action, and this is the third action. So let's see how all of this is now implemented in the React framework. Remember the TAO, thought, action, and observation. So we'll do this in 2 cycles of thought, action, and observation. In the first cycle, the thought should be, I should probably search the web first, right? Then the action will be Google the price of MacBook Pro, right? That's the tool which I'm using here. Remember, now here everything is coming together, what we have learned in this lecture. The soldier has to now use the tool, and the tool which I'm using is web search. Then I will search Google the price of MacBook Pro. Then I will get this price in dollars. Now my observation is that I have got this price in dollars. So thought is done, action is done, and my observation is done. Then comes the second cycle of thought, action, and observation. The second cycle is that I need to convert this into euros. That's the second thought. I need to convert this into euros because I want the price in euros. So how do I do this? I need to use a currency converter. So to do this, to convert this into euros, I need a calculator. So that's when I perform the second action, which is using a calculator. And for that, I use the second tool. So the tool number 1 is web search and tool number 2 is the calculator, which I use from my toolkit. Then I perform this action of converting this $1299 into euros, and I get that the price in euros is 1104.15 euros. And then I record my final observation. The final observation is that the MacBook Pro would cost 1104.15 euros. Here I showed you two cycles of the React pipeline. So thought, action, and observation. This is the first cycle. And then thought, action, and observation. That's the second cycle. And then here you see we have got the final answer. Some problems are more complex, so then they will need multiple cycles of React. But for a simple problem like this, we can just do 3 cycles and get to a very useful answer. I hope this shows you how we use the thought, action, and observation framework and how it's very similar to how humans think. Remember, just LLMs cannot do this. Why? Because of the green section here, and those are tools. LLMs are combined with tools, and that's when they become agents. That's the first thing we learned. The second thing we learned is that agents operate using the React framework, which consists of thought, action, and observation, and there can be multiple cycles of thought, action, and observations. Alright. So now what we are going to do is that this exact same example what we saw, we are going to build out an application in LangChain, which searches the web for answers and then performs calculations with a calculator. These are the two tools which you used, if you remember. So that's the tool number 1, which is the web search. This is where we have to search the price of the MacBook Pro in dollars. And this is the tool number 2, which is using a calculator. Let's solve this problem using code right now. So I'm going to jump to Google Colab. A few things before you get started. I'm going to share this Colab file with you, and it's of course taken from the hands-on large language models book. First, you will need to install these packages: LangChain, OpenAI, LangChain _OpenAI, transformers, etc. Just do it once and then you can run all the examples in this code file. Once you install these packages, you can scroll down below to a section called agents, right? And then we can directly get started. So we have to use a large language model. As you see here, agents, the core component of agents is LLMs, but LLMs equipped with tools. So the first thing we have to choose is what is the large language model which we are going to use. And I'm using OpenAI because it's awesome. And to use OpenAI, remember that it's a closed source model. So we have to use the OpenAI API key. So here's where you have to load your OpenAI API key. You can even use these keys. You can use this secret keys section in Google Colab, this key symbol here, so that you don't expose your key. So I'm not sharing my key over here, but the place you can find this is that you can go to platform.openai.com. You'll need to log in here, and then when you go to dashboards, you can see the API key, and then you can generate your API key. Let me show it to you here actually for reference. So if I continue with Google, if you have an account, you can just sign in. So if you can then go to dashboard, then you will see API keys over here, and then you have to just click on create a new secret key, and then click on create key, and then copy that key, and then you have to paste that key over here. I suggest you can save it using these secrets so that you don't expose your key in the code. Then we have to define the OpenAI model which we are going to use and some parameters. So we are going to use the GPT 3.5 Turbo. Remember, whenever you use API calls like this, there is a cost which is incurred per call. So you have to choose the model appropriately. If you use advanced models like GPT-4, the cost will be a bit more. We are doing a simple example, so GPT 3.5 turbo will suffice. Temperature equal to 0. So temperature controls the creativity of your output. If temperature is very high, your output will be variable. It will be a bit random. So temperature is the artist factor. The more temperature, the more artistic the responses will be. Right now, we just want proper responses without too much variability. So I'm putting temperature equal to 0. And this chat OpenAI is a package which is provided through LangChain _ OpenAI itself. So this is the OpenAI LLM which we have defined. That's the first thing you have to do in the code. So let me write down the steps you have to do in the code. The first thing which you have to do is define the LLM which you have to use. That's done right now. So let's move to the second step. The second step is that we have to define the template. And this is strictly not necessary. So you don't have to do it every time, but I'm just showing it to you from scratch so that you understand how the React template works with LangChain. So this is the React template which I have defined over here. Answer the following questions as best as you can. You have access to the following tools. So the question, so see T, A and O, thought, action, observation, exactly what we saw on the whiteboard over here. Thought, action and observation. So here we are just telling the agent the template it should follow when it receives the prompt. So first it will receive a question, the input question which you must answer. Then you should always think about what to do. Then we are telling you have to then choose the action which you have to take using one of the tools. This is where the tools are selected. Then we deploy the action and then we observe the result of the action. And then this TAO framework can repeat multiple times. For example, in this whiteboard over here, the TAO framework repeated 2 times. And then the final answer is revealed. I now know the final answer. The final answer to the original input question is this. That's the template. So we have to define a prompt using the prompt template. And in the prompt template, we mentioned that template equal to React template. Template equal to React template, and then input variables are the tools, tool names, input and agent scratchpad. For now, you can just worry about the tools and the tool names, which we have to provide next. So once the React template is defined, the third thing which you have to do is provide tools. Provide tools which the agent has to use. Now, one more thing I want to mention here is that you don't have to define the React template custom every time like this. Because I asked ChatGPT regarding this, do I always need to define such a template? And then ChatGPT said that you don't always need to define a custom template. LangChain provides several built-in agent types and reasoning strategies that come with predefined templates. So for example, LangChain has this predefined zero-shot React agent. Then LangChain has a predefined conversational agent, etc. So you don't have to custom do it every time. You don't have to write this custom template. Just keep it in mind. The third thing we have to do is provide tools, right? So this is where I want to show you a list of all the different tools which can be integrated with LangChain. So this is a repository called Awesome LangChain, which shows all the different tools which you can integrate with LangChain. So you can scroll down below and go to agents, and here you can see all the tools you can integrate. You can, if you want to build a research, let's say if you want to build an agent which does scientific research, you can integrate this GPT researcher tool here. You can, there are several tools which you can integrate. So for example, this is a visualization and debugging tool for LangChain workflows. This is LangChain Auto Evaluator. This is a toolkit for creating and deploying LangChain apps. This is a toolkit which is quite popular. It has 7.4k stars. It's to build Python LLM apps very quickly. Then this is Llama. GitHub is a Python library with built-in which is built with LangChain framework, etc. So there are several tools which you can integrate with LangChain. For us, the tools which we need are, we need a search result. We need a tool which searches the web. And second, we need a calculator to be integrated. So to integrate the search results, we are going to use this DuckDuckGo search results, which is a tool which can be integrated with LangChain. And for people who are not familiar with DuckDuckGo, you will see that it's a search engine basically, but it claims that it maintains privacy. So it's much better than Google, where a lot of information is shared and we are not sure what's going on, how much of it is private really, and how much of our information is public. But DuckDuckGo prioritizes your privacy. So we are using this DuckDuckGo search results tool, which can search the web essentially. So that's what we'll be doing in the code next. From LangChain.tools, we are importing DuckDuckGo search results, which we saw over here right now. And then we have to define the search tool equal to tool. And then we have to say name equal to DuckDuck description. We have to give the description so that the agent knows what this tool does. So here we are saying it's a web search engine. Use this as a search engine for general queries. And then we have to give the function search.run. So whenever this tool is called, it will search the web. The second tool which we are going to use is an inbuilt tool which is called LLM Math. That will be the calculator tool essentially. And the package which we use to access inbuilt tools is load tools. So here you can see we have prepared the tools. We are using two tools. We are using load tools, and the first tool which we are using is LLM Math. It's an inbuilt tool. And the second tool which we are using is we are appending the search tool, which is the DuckDuckGo tool. One more thing which you have to mention when you use this load tools is you have to specify the large language model which you are using. That's very important. So again, LLMs are at the core of agents, right? You cannot run agents without defining the LLM because who does the thinking? The LLM has to do the reasoning. The agent is good for execution or for deploying the tools. That's why you have to mention the LLM over here. And this LLM is the OpenAI underscore LLM which we saw right over here. Okay, so until this stage what we have done is we have provided the tools, and then the fourth step what we have to do is we have to define the agent. We have to define the agent, and to do that we use this create react agent function using LangChain.agents. And here we have to mention the LLM, we have to mention the tools, and we have to mention the prompt. Remember, the prompt is this prompt template, which is the React template which we created before. So the agent is defined using this create react agent, and here we have to actually mention three things. We have to mention the LLM which we are using, we have to mention the tools, and we have to mention the prompt if we are using any prompt template. So that's how we have to define the agent. And the fifth thing is we have to execute the agent. This is when we have to finally give our input prompt and what we want the agent to do. So the last step is this agent executor. Actually here, before we execute the agent, what we have to do is we have to define the agent executor. So here you see we have defined the agent executor now, and where we have to pass in the agent which has been defined before, and again we have to pass in the tools. That's it. So the agent executor is defined, and then after that we have to run the agent executor. Run the agent executor with user input. So this is the action which we want to be performed. So the way to run the agent executor is to type agent executor.invoke, and then we can say that the input which we are giving is what is the current price of a MacBook Pro in USD, how much would it cost in euro if the exchange rate is 0.85 euro for 1 USD. See, this is the problem which we want, right? I am in Europe. I am in USA, sorry. So first I want to know what's the price of a MacBook in USD. And then I want to know how much it would cost in euro if the exchange rate is 0.85 euro. So let me run this right now. And here you will see the response. And this is actually incredible because it exactly follows the thought action observation framework which we saw, right? So first it thinks I need to find the current price of a MacBook Pro in USD and then convert it to EUR using the given exchange rate. That's the thought. Then it enters the action. The first action is DuckDuck, which means it uses the search engine, and the action input is current price of a MacBook Pro in USD, and then the output which it gets is let's see. today. So it actually even mentions the link where it gets the all the output from. So it's searching essentially. So it has collected all the output which it has got, the sizes and everything related to. So see, now it has mentioned that I found the current price of a MacBook Pro in USD. This is the observation. We have found the current price of the MacBook Pro in USD until we have reached this point, and then it thinks again. So that's the second chain of the TAO. So the second thought is, now I need to calculate the price in EUR with the exchange rate, right? That's the second thought. So we are entering the second chain right now, and then you will see that now we use the second tool. So then the second tool is, or the action is, we are using a calculator, and then we are multiplying 2499 with 0.85, and the answer is 2124.15. So it knows the final answer. I now know the final answer, and then the final answer is the current price of a MacBook Pro in USD is $2499. If the exchange rate is 0.85 euros for 1 USD, it would cost approximately 2124.15 euros. Amazing, right? This is exactly what we wanted. These are two cycles of the thought, action, observation framework in action. So the agent very seamlessly used two tools, DuckDuckGo, and the second tool which it used is calculator. Now you can think how many awesome things you can do with it. You now have access to all of these tools which LangChain can be integrated with. Think of so let's say if you're a researcher, you can build an agent which reads research papers. You can build another agent which summarizes those research papers. You can build another agent which finds gaps in the research. So you can use this thought, action, observation framework for these three agents. I'll maybe make more complex tutorials later on agents. But for now, I just wanted all of you to build your first agent and deploy it. So you know what is the hype around agents, why is there so much investment and funding flowing into this space, and then why are people saying that the world is going to be agentic. I really felt happy when I ran this for the first time. So that was my first introduction to agents, and it was incredible to see an agent just executing all of these actions like a human would do. This example looks pretty simple, but if you have understood this opens the doorway to do a huge number of complex projects. So this actually brings us to the end of the lecture, where we got some amazing results, and hopefully I have demonstrated the power of agents to you. There are a couple of things to take away from this lecture. The first is an LLM equipped with tools gives us agents. That's the first takeaway. The second takeaway is agents operate on the react and action framework, and within this there are three pillars. The first is thought, the second is action, and the third is observation. So I call it TAO. First you have to think, then you have to decide to take action. So when you take the action, you also have to choose the tool, and then you deploy the tool, you see the observation, and then you repeat this TAO framework until you reach the final answer. When you reach the final answer, you just output that answer, and that's how agents actually work. Now, once you understand this framework, I think you can at least theoretically appreciate the example which you started with, the flight agent. It's completely possible to do this using the thought, action, observation framework. Right now, we just converted the price of a laptop to euros, right, and searched the web. So I showed you how to search the web. You know the first part of this. The task which I want to give to all of you is, can you integrate agents with the second and the third part? Where first you search for the flights, that's good. Then you have to search the best flight. And then you have to integrate payment gateway. Can you try to do this? It will be an awesome exercise, and it will probably be an amazing product. I would like to use such a product to instantly book flights. So thanks a lot everyone. I hope you like this lecture, which is a mixture of theory on the whiteboard plus Google Colab. I'll share this code file with all of you, and now you can start your journey with agents. Thank you everyone, and I look forward to seeing you in the next lecture.